All right, let's check these notes from today. Continuity and the IVT. So let's see how these things mesh together and why we teach you them at the same time. So remember, here's your continuity. You have to have a limit that exists. We have to have C being defined, and the limit at C needs to be the same as the Y value at C in order for the function to be continuous. Okay, so let's use that definition to prove that the function is discontinuous for the given value of A. Okay, so let's go through and disprove. So we have to do these things, right? We got to do these things. In order to disprove something, we're going to use the definition. So, number one, does the limit as x approaches 3 of our function exist? Right? That's the first thing. Does the limit, because if the limit doesn't exist, bam, we have shown that it is discontinuous. Okay? So what's happening at 3? So direct substitution, what do we get? Right? That's how we evaluate limits, is we directly substitute. And that looks like it's 9 minus 3 minus, that's 0 over 0. 0 over 0 means we have to do some other manipulation. So how do we manipulate a polynomial over a linear? We factor these things. So this factors to x minus 3 and x plus 2, right? Those are numbers that multiply to give me -6 and add to give -1. Okay, that's how we do this factorization. In your numerator, that quadratic factors to x minus 3 and x plus 2. And on the bottom, we still have your x minus 3, which divides, right? X minus 3 divides x minus 3. So what is the limit as x approaches 3 of our function? Well, dang it, it's 5. When I plug a 3 into here, 3 plus 2 is 5. Well, that kind of proves number one is true, actually. The limit at positive 3 exists. All right, so if that part didn't do it, now we move on to the next part. Let's test number 2. F of C is defined. So what do I get when I plug positive 3 into my equation? I get 0 divided by 0, which is a special type of undefined, right? I didn't get 5. That's the beautiful thing, is I did not get 5. So the limit as x approaches 3 of our function, it does not equal the y value at 3. Okay? Does not equal the y value at 3. So that is why our function is discontinuous. The limit does not equal the y value. Okay, here is our next example. Use the definition, right? So we're going to do the existence of a limit versus the y value right there, and we're going to show that they are not the same thing. Right? That's what it means to prove that it's discontinuous, right? Saying that it's discontinuous is not enough. You need to have a reason why, a mathematical reason why. Okay, so we have two graphs where 0 is your fence, right? So we have a fence. Shall we sketch this? Let's just do the math first. So let's find the limits as x approaches 0 from the left of our function. Okay? So
this is a different story.
what we're going to do is decide which of our two functions, the top -2x plus 2 or the bottom x squared plus 1, is on the left side of 0. And that's going to be the top. Because if you're less than, that means you're on the left side of the graph. Okay, so we're going to plug 0 into that equation. Okay, so -2 times 0 plus 2 is positive 2. So from the left, our graph is going to approach positive 2 as x approaches 0. Okay, and now we're going to flip it around and do the right side. Right, we have to do lefties and righties. So the right side is the greater than side. So we're going to plug 0 into x squared plus 1. So that would be 0 squared plus 1, which is 1, not 0, which is 1. So, does the limit exist? No. The limit as x approaches 0 from the left does not equal the limit as x approaches 0 from the right. Okay, that's our definition of a limit. The left side and the right side both approach the same value. So that means that the limit as x approaches 0 does not exist. Right? And that's the first of our definitions of continuity, is that the limit exists. So if the limit doesn't exist, therefore f of x is discontinuous. Right, there's our therefore, your 3 triangular dots. Therefore, f of x is discontinuous where? At 0, right? So we have to say who we're talking about. F of x is who we're talking about, right? What is the behavior or the property, right? Discontinuous, and then where it's going to be. Okay, so then this is the third way that we're going to be tested about continuity. So let's see, what they want to know is what value of k, and there's 2 k's. There's a k in our top equation and there's a k in our bottom equation. Okay, so what do we need to do? Well, if our function is continuous, right, if it is continuous, then the y value from your top equation, right, from when x is greater than 0, is equal to the y value from your bottom equation, right? That has to be true. The limit from the left equals the limit from the right, means those both graphs are going to the same y value. Okay? And if that's true, then our function is defined there also, right? We have to have a y value, and because it's less than or equal to, that means we are going to have a y value there also. So that one's taken care of. So we want to know, when will x squared plus kx be equal to 8x minus k for what value of x? For x equals 2. Okay? The y value from the top equation needs to equal the y value from the bottom equation for x equals 2. Okay? So let's do our substitution. 2 squared plus 2k equals 8 times 2 minus k. So you set the top equation equal to the bottom equation and you replace x with 2, right? Because that's the interesting part. That's where these two graphs come together. The left side is a quadratic. I mean, I guess the right side, since the right side is greater than. This is a quadratic, continuous everywhere. This is a linear, continuous everywhere. So we really just have to check at 2. So I've got 2 squared is 4 plus 2k equals 16 minus k. Math says to get the k's on the same side. 3k. And get the numbers on the other side. 16 minus 4 is 12. So if we had a k value of 4, then your function would be continuous for all values of x. Okay? That's how you do these type of continuity problems. You're given 2 equations, and we want to know when x is 2, their y values have to be the same. Right? That's our understanding of continuity. And the limit from the left will equal the limit from the right, will equal the y value at that spot also. Okay, so when it says use the definition, that's what it's talking about. Okay, these three things are the definition of continuity. Limits there, check. We have a y value there, check. And the y value is the same thing as the limit. There you are. Pretty simple.